This chapter is called Amino Acids and Peptides, but what it's really about is starting the process of building proteins, which is what we're trying to do here in our first big unit. Now, before I get into the actual unit goals, I want to show you a real protein. I've probably shown you some of these before, but this is a complicated mess, and our goal eventually, after a few more chapters, is to understand all of this mess. Let me tell you that proteins and peptides are simply long polymers of amino acids, and they get all folded up in what looks like a random mess, and it's not random at all. Let's back up and talk about the overall name of this chapter. It's called Amino Acids and Peptides. Amino acids are the components that we're going to use to build proteins. Now, peptides are just small proteins. They're just amino acids linked together into short chains, and that's going to be terminology we use a lot, peptides and proteins. So what are our unit goals? Explain how the structures of amino acids affect their properties. We have to learn about what the structure is like first, then we can talk about the properties. And once we've learned the amino acids, there's 20 of them, then we're going to build peptides, that is peptides/proteins from those amino acids, and analyze the overall protein or peptide structure. Now, in order to set you up for this chapter, I want to give you an analogy that we're going to use a lot. Peptides and proteins are linear chains of amino acid units. And I like to use this train analogy to help you think about that. A train is an awful lot like a protein in some ways. It's got a beginning and it's got an end. It's linear and it's composed of pieces, like these train cars, that are linked together over and over again in the same way. And what we have to understand is that, like with trains, peptides and proteins have functions. And let's just take a look at these two trains. It's obvious, I hope to you, that the first one is a passenger train. There's a lot of passenger cars on it and a locomotive. The one below it is just a little toy train that is we might call it a construction train. Now, these have different purposes. There's some important similarities between these two trains. They're composed of train cars, and they're held together by the same types of linkages between those cars. However, their functions are determined by the pieces that make up them, that is, the train cars. To make a passenger train, you need passenger train cars. To make a construction train, you need something that can carry dump trucks and bulldozers and things like that. It's an awful lot like proteins. We have 20 amino acids. They each have their different properties, and we can build them into chains using those same 20 amino acids and the same linkers. But which amino acids we choose ultimately is going to be telling us what type of functions we're going to get out of the entire peptide chain. So I just wanted to introduce that to you as we think about these scientific goals and understand that it's going to take us a little bit of time to get built up to something as complex as this protein down here. By the way, what is this protein? This is a protein that we study in the lab. It's a bacterial protein called beta-lactamase. The structure was actually determined by some students that worked with me many years ago. This beta-lactamase is found in bacteria that have acquired the ability to destroy antibiotics of the penicillin class. And if a bacteria has this enzyme, which is a protein, it can destroy some of our most powerful drugs that we give to treat bacterial infections, and it can therefore kill you. This is really a very dangerous protein, and that's why we study it. So anyways, it's a nice example of a protein, and we will start the process of building proteins like this in this chapter.